All right, so our last section of Chapter 2 is Section 2.10. It is called Solving Inequalities by multiplying or dividing. So if you remember back to lesson 2.9, we solved inequalities by adding or subtracting. So now we're just going to be multiplying or dividing. So whenever we have a problem where we see multiplication, we know we need to do the opposite, which is divide, to get our answer to equal 1 or just regular old x. So let's review again how to do that with an equals sign. So if I have the problem 3x equals 15, right here I am multiplying. So to get rid of multiplying, I need to divide both sides by 3. So 3 divided by 3 is 1. So on this side I get x equals 15 divided by 3 gives me 5. So my answer would be x equals 5. Let's do another reviewing one. So if I have x divided by a negative 2 equals 6. To get rid of the dividing, I need to multiply both sides by a negative 2. Okay, so a negative 2 divided by a negative 2 leaves us with a 1. And remember, we don't need to write 1x, because if we just see an x, we know that that's already just 1x. And 6 times a negative 2. If I have a positive number and a negative number, my answer is always going to be negative. If they're opposite signs, my answer is negative. If they're the same signs, my answer is positive. And then I just need to multiply 6 times 2 and get 12. I'll write that down so that you guys write it on your notebooks to remember. We'll do capital letters. Remember. Multiplying it. When we multiply and divide, opposite signs means it's going to be negative. Same, oops, I keep pushing buttons here. I'm getting too close to the bottom. Same signs means my answer will be positive. We'll just put a little abbreviation here. So if they are the same signs, they will be positive. If they are opposite signs, they will be negative. That is what we need to remember. I mean, the more we practice this, you guys, it will seriously, you just look at it and you know. That's the point where I'm at right now, and the more we practice, that's the point that you will be at as well. But when we're starting off, we have to just remember all these little rules, keep practicing them. So again, it's just like when I ask you to add. You know that you're going to add 1 plus 2, you can do it off the top of your head. Multiply 2 times 12, multiply it off the top of your head, okay? So that's the way we want this to become, because we practice it so much that we just know what the answer is going to be. All right, let's do some problems that aren't reviewed. Let's do some new problems about what we're going to be talking about today. All right, we have a little thing to write down. To solve inequalities, if you multiply or divide by a negative number the inequality ITY. Okay, let me try that again. Inequality switches direction. Oh my goodness, you guys. The inequality sign switches direction. All right, I wanted to take a couple seconds, read that again. Here we go. Let me fix my C quick. If you multiply or divide by a negative number, the inequality sign switches direction. Let's read it again because that is oh so important. If you multiply or divide by a negative number, the inequality sign switches directions. Okay, that is something that is so very important. We got to get it in our heads. We better read it one more time. Say it with me. If you multiply or divide by a negative number, the inequality sign switches direction. Let's practice that because that is oh so important. So here is our first example. Solve and graph. Okay, so number 1 says 6x is less than 18. Do we have to multiply or divide by negative signs? No, so our sign will stay the same. So right now I have 6 times x. Whenever we see a number next to a variable or a letter, that means we need to multiply those two numbers together to get our answer. But since of the variable is an x and we're solving for x, we want to make it 1x. So how do I make 6x into 1x? I divide both sides by 6. I can bring down that inequality sign as the same because I did not multiply or divide by a negative number. 6 divided by 6 is 1. I am left with x is less than 18 divided by 6 or 3. Now I have to graph, which again is just a number line. 1, 2, 3, go a little bit past, 4, 5, 6. That's a good number. All right, should my circle be open or closed? It should be open because it is not equal to 3. So that means it could be like 3.1. It can get really, really close to 3, our answer, to make this sentence true, but it could not be 3. X is less than 3. Less than, that means our sign, our line, there we go, goes to the left. There's our answer. Let's try another one. All right, number 2 says x divided by 3 is greater than or equal to negative 7. Okay, I see a negative number, but watch very closely. We have to pay really close attention to see if we have to flip our inequality sign or not. So right now I have x divided by 3. To get rid of that and to get 1x, I need to multiply both sides by 3. Multiply by 3. Okay, so 3 divided by 3 is 1, or just regular old x, is greater than or equal to negative 7 times 3. Okay, did I have to multiply or divide both sides by a negative number? What I'm looking at is this number here. Is that number negative? No, it is not. So my sign stays the same. So now I just have to do what is 7 times 3? It's 21. If I go back a couple slides, I see that if I have different signs, my answer is going to be a negative number. All right, now this one's going to be a pain to graph because it is negative 21. So let's go by 2's, why don't we? And since I know it's going to be negative, I'm going to put my 0 way over here so I can have a big amount of room to put down my number line. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, 16, negative 18, negative 20, negative 22, negative 24. Okay, so is it going to be equal? Could it be equal to negative 21? Why, yes, it could. And where would negative 21 be? It would be about right here, right between negative 20 and negative 22. Okay, so I'm going to put a closed circle, and it is greater than or equal to, so greater than goes to the right, GR. Here we go, draw that line over there, draw an arrow because any number up to infinity could answer this problem. A positive infinity, not a negative infinity though. All right, let's try another. Number 3, x divided by negative 2 is greater than a negative 6. All right, here we go. X divided by negative 2. So to get that negative 2 to equal 1, I need to multiply both sides by a negative 2. Whoa, 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 whoa. What did our sign say? What did our rules say we had to follow? If you multiply or divide by a negative number, the inequality sign switches directions. Did I just multiply or divide by a negative number? Why, yes, I did. Okay, so when I bring down my sign, I need to switch it now. Did you catch that? I switched it. Why did I switch it? Because I multiplied by a negative number. Whenever we multiply or divide by a negative number, we have to switch our inequality sign. Now I just go through and do things as usual. I have a negative 2 divided by a negative 2, which would give me 1. So I am left with x is less than negative 6 times negative 2. If my signs are the same, my answer will be positive. So it would just be a positive 12. Did you catch that? If my signs are the same, my answer would be positive. Same on this side, you guys. Negative 2 divided by negative 2, they're the same side, so it's going to make a positive 1. All right, now we need to graph it. It's going to be a positive 12, so I'm going to put my 0 way over here because I want to make sure I have room. And I might as well count up by 2 to make things a little bit faster for me. 2, 4, 6, 8, 10, 12, go a little bit past, 14, 16, 18, since I have room, might as well. Okay, is it going to be open or closed? It is going to be open. So I could not say that 12 is less than 12. That's why it has to be open, because 12 isn't less than 12. If I said 11.99999 forever is less than 12, that would be correct. Okay, so that is why we have to keep the circle open, because it doesn't equal 12. 12 is not less than 12. Okay, so then I need to say, does it go to the right or does it go to the left? If it is less than, it goes to the left because they both start with L's. That's not why, but that's a little trick we can use to remember it. Less than left, and there is our answer. Now, this was the first example where we had to switch our inequality sign. The reason we did that is because if you multiply or divide by a negative number, the inequality sign switches directions. Not when you add and subtract, only when you multiply or divide by a negative number. Let's do some more problems. Okay, number 4 is negative 3x is less than or equal to 15. Positive 15. Okay, so right now I am doing negative 3 times x. And negative 3 times x, I want to get that negative 3 to equal 1. I can't get it to equal 0, but I can get it to equal 1. So that means I need to divide both sides by a negative 3. Divide both sides by a negative 3. When I say both sides, I mean both sides when that inequality is there that's putting up like a wall. Okay, so both sides I need to do that to. So negative 3 divided by negative 3 is just a regular old x. Now alarm bells should be going off in your head because I am dividing by a negative number. And our rule states if you multiply or divide by a negative number, we need to switch the inequality sign's directions. So when I bring down my sign, I need to switch it. Instead of negative 3x being less than or equal to, now x is greater than or equal to 15 divided by a negative 3. They are opposite signs. One is a positive, one is a negative. So my answer is going to be a negative. 3 goes into 15, 5 times. Okay, so now I need to graph this. This one's a nice easy one. I'm going to put 0 right there because it's a negative number. Negative 2, negative 3, negative 4, negative 5. Keep going. Negative 6, negative 7. Okay, now x is greater than or equal to. So since it is equal to, I'm going to color in my circle. It is a closed circle because it can equal 5, negative 5, sorry. And x is greater than or equal to, so greater than goes to the right. Draw our arrow on the end, and we are good to go. Here is the box where your answer, that should go around your answer. Remember to box in every single one of your answers. I don't have time to sit there and try and figure out exactly where your answer is. I need that answer to have a box around it. All right, number 5. We have one more after this. 4x is greater than a negative 12. 4x is greater than a negative 12. Okay, so on my barrier, this side is the side with the variable. That is the side that I'm trying to get the variable alone. So right now I have 4 times x. To get rid of that 4 and make it a 1, I need to divide both sides by 4. Did I divide by a negative number? I didn't. So my sign's going to stay the same. 4 divided by 4 is 1, so I just get an x on this side. Negative 12 divided by 4. I know my answer is going to be negative because they have opposite signs. One is a positive, one is a negative. So when we divide or multiply those numbers together and they are opposite, I'm going to get a negative number. So now I just have to do what is 12 divided by 4, and I know that answer is 3. So here's my solving it. This is me solving it right here. Now I need to graph my equation. Might as well put 0 over here. Negative 1, negative 2, negative 3, negative 4, negative 5. Is my answer, on my graph, should my circle be opened or closed? It should be open because negative 3 is not greater than negative 3. That does not make sense. Greater than, go to the right. And boom, we are finished. Now let's do one more problem together. All right, and number 6. If I have the problem, negative x is less than 16, you might be saying to yourself, wait a minute, But x is there by itself already. There isn't a number in front of the x. There isn't a number divided by x. But the reason why this problem is not solved yet is because of the negative sign that is in front of the x. We could rewrite this as negative 1x is less than 16. Now I need to get rid of that negative 1. If it was a positive 1, we would be okay. But that negative 1 is going to throw everything off when we graph our answer, so we have to get rid of it. How do I get rid of a negative 1 times x? I divide both sides by negative 1. Now something should be going off, bells going off in your head or something here, because what am I doing to both sides? I am dividing by a negative number. So when I bring down my inequality, I need to switch it from less than to greater than. Now, negative 1 divided by a negative 1 is just 1, so it would be x. The reason why that is a positive 1, again, is because they have the same sign. And when we multiply or divide numbers with the same sign, our answer will always be positive. Now for these guys over here, I have a positive and a negative, so I know my answer is going to be negative. Opposite signs, negative. Same signs, positive. So 16 divided by 1 is just a regular old negative 16. So let's graph that. Let's go by 2's. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, keep going, negative 20. I'm saying 2 past is probably good. Is my circle going to be opened or closed? It is going to be an open circle because it cannot be equal to negative 16. So I'm going to draw my open circle. X is greater than negative 16. Greater than, that means our line is going to go to the right. Greater than right. And we are finished. Please remember, if you have any questions about this, you guys, come in before school, come in after school, come in after lunch. Just let me know beforehand so I can make plans, and I would be happy to help you. Also, I always am on Edmodo. If you have a question over at night, something you have to do, please just contact me on there, and I would be happy to help you. Thanks for watching.